So my name is Arakelian, and I'm going to talk a little bit today about a transition that we went through at a company called Dell EMC. So I actually work for a company called EMC. Have people heard of EMC before? A couple of people, right? We build storage devices. They're fantastic, right? How many people have heard of Dell? I would assume everybody. Right? So a couple years ago, we merged together, and now it's Dell EMC. So I'm on the more traditional EMC side, working in their enterprise storage division. Now, I'm traditionally a software developer, engineer kind of guy. And I've always delivered product. A couple years ago, I had an opportunity to run a DevOps group for our enterprise storage division. Now, how many people do DevOps or have heard of DevOps or do DevOps-y things, right? So I never done DevOps before in my life, ever. But I deliver a lot of product. I knew how that kind of stuff worked, right? I knew how to basically take a set of changes, run them through software development lifecycle, go through the appropriate testing that we needed to do to finally deliver a quality product, or at least I thought I did. So it was interesting because when I took the position, our senior vice president at the time said, we really need to implement some changes around our testing and the quality of our product. And I said to myself, why'd you hire a DevOps guy to change your quality of your product? And they said, well, we really need to change the culture and how people think about how they develop software, right? So stepping back, we talked a little bit about in this talk here, it's about silos, right? So how many people work in siloed environments? Yeah, so I worked in a super siloed environment. QA was QA, they did all the testing. And development was development, and they did all the development. They didn't test, that wasn't their job. They wrote the code, threw it over the wall. The QA guys tested it and said it worked or it didn't. Threw it back, and they got into that tennis match all day long, right? Wasn't very efficient or effective. Not only that, overall, organizationally, it cost us a lot of time, money, and energy, and we got quality. We produced something that worked most of the time, but what we were building didn't or couldn't work most of the time. It had to work all of the time. So what I wanted to talk about today was how we began to move towards a continuous integration and continuous testing environment. All right. So it starts with culture changes. And it's really a journey. It's not necessarily, you don't bring in a tool and say, hey, we're going to now do continuous testing, and everybody's just going to use this tool, like Vector, for example, and everything's going to magically change. It certainly helps to have the right tools in place, but it's a culture, it's a philosophy, right? So, when we first started, we kind of had to step back and say, all right, so what are our common philosophies? A lot of people were pushing, well, we need to be agile. We need to, run Scrum because that will help us deliver software. Why? I mean, what about that kind of methodology is going to work for us? So what do we really believe in as a team? What does everybody believe in as a team? What are our philosophies? And, James talked a little bit about philosophy. Philosophy is really, really critical in order to have common goals. And when you talk about quality isn't just done by a group of individuals, it's done by everybody. And everybody has to believe that they are producing a product that's of a particular quality. If they don't believe that, then as a team, you're going to suffer. So when you talk about philosophical examples, right? Enabling engineering through continuous building, delivering, and testing. Building business confidence by increasing traceability through transparency. Work towards having reliable and stable baselines of code. I mean, these are all common philosophies that people want to or should want to stand behind, right? And those philosophies might be different per team. It's up to the team to create the philosophies. But those philosophies end up shaping the operational vision, strategic goals, and processes. We have to identify that software development is a manufacturing process. Code comes in, a bunch of stuff happens, perhaps that building and testing, product comes out. It's a manufacturing process, like any other manufacturing process, right? Every commit must have some kind of associated testing. Like John was saying just before I came up. We want to test as early and often as possible, all the time. It's not just something that, again, a tester does. Those testers need to educate everybody in the organization so that they know how to test to some degree. They don't have to be experts. Not everybody is going to have the same skill sets that some testers have, but they nominally need to be able to communicate what we're trying to accomplish from a testing perspective to everybody throughout the organization. Vision, strategic goals, and processes are realized through consistent workflows across infrastructure. Meaning if I am part of a component group and you're part of a component group, we should be working the same. Your component and how it gets created and tested should be no different than how my component is created and tested. You can accomplish this through things like promotional-based continuous testing, unit testing, functional testing, feature testing, integration testing, customer acceptance, right? That promotional-based model allows you to, at every checkpoint through your life cycle, have fact check in place. Did I pass my unit tests? At what percentage is my code coverage? Et cetera, et cetera, et cetera. And those metrics can vary between teams. There are no magic metrics out there that say, if you use these 5 things, you will always have the best code out there, right? And by the way, I expect it to change and evolve as your product changes and evolves. So you have to be looking at those kinds of metrics, but with no metrics, like we just talked, like I think Gianna was talking about, or there's a question about test pass failure rates, right? So that's an interesting metric. By itself, though, it's pretty useless, right? Until you have multiple dimensions, then you can get a whole story of the quality of your code. So our business case, and this is where my story comes in. So imagine you take a DevOps job and you're going to fix quality for a 25-plus-year-old embedded product that's in all aspects of the industry, focused on enterprise customers, right? And finance, financial institutions. Major banks depend on the quality of this product and the reliability of the product. Medical, industrial, education, right? Imagine this product is one of the first movers in the particular space in the storage market, right? When back in the 80s, the time to market deliverables were in years, not months, right? And your product culture was 100% engineering focused. everything was done manually, primarily due to the complexity of the product. Manual testing, manual integration, manual build and release. Everything was done manually. And when I mean manually, I mean really manually. As in manufacturing, we talked about software as a manufacturing line. I mean manufacturing would literally take the device, load software on it, and then just click through use cases. Boom, 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 boom. Looks good, ship it. Now, maybe 25 years ago, that was an okay model, right? But fast forward to today, we're no longer in a niche market. Storage is a commodity. There's lots of different groups out there that are in the storage market. I'd go as far as to say IT is a commodity today, right? We have high productivity expectations, faster delivery expectations. We have globalization pressures. We have less available people resources. We have larger market competitions. Quality and time to market are key elements for success. So how do we transition that organization to continuous integration and continuous testing to try to address some of these problems that we have and some of the pressures that we have? It took a significant amount of time in order to try to accomplish this, but we have made some significant progress today. And what we started with was trying to build a shift left culture. How many people have heard the term shift left? A bunch of people. All right. So shift left is really about pulling testing back to the left side when the code is written, right? So when I first got to this organization, I interviewed a lot of people. And from the interviews, I talked with testers, I talked with engineers, I talked with product management, a lot of different people. And it's really interesting because when I talked to testers in our QA department, they said, well, I can't test something until the product or the feature is ready. And I said, what does that mean? What do you mean, ready? Well, when it's stable, like when I can test it. And I said, wow, that's kind of crazy, right? So basically it's done, and now you're going to come in for the first time and begin to click around. I said, well, who defines how it works? Oh, well, the engineer tells me. Oh, well, that's convenient, right? So you've got the guy that wrote it, the maker, right? Telling the tester, hey, yeah, it's supposed to work that way. Yeah, it's not, don't worry about it. It's supposed to work that way. Okay, well, that seems a little counterintuitive, right? So when I talked to engineers, I said, so how do you guys test your stuff? And they said, we don't. The testers test our stuff. I said, what? How do you mean? And they said, well, we write code, and then, I give it to Joe, and Joe goes ahead and does some stuff and says it works or not, and then he tells me that, hey, it didn't work, or it did work, great, good work, and we move on with our lives, right? So we started really talking about shifting left, testing early and often. Testing starts when the first line of code is written, all the way through to customer acceptance. Our testing experts are there along the whole way. In fact, I did find some gems of people in our organization who said, you know what, Adam, I don't agree with you. Testing doesn't start when you start writing code. And I said, oh, okay, so when does it start? At the requirements. And I said, you are totally right. I said, you are absolutely right. Yeah, totally, right? It starts at the requirements level. How am I going to, do I understand what this thing is doing, this feature is supposed to do, and then how am I going to test it? It starts all the way, that's all the way left, right? So we really started to talk about a shift left culture. We really started taking our testers who really believed in this shift left cultures and started to disseminate their tacit knowledge across the organization, talking about how important it is to test as early and often as possible. And our engineers started to and began to see value in doing simple things like writing unit tests and writing functional tests, because the code would actually work correctly as designed in the documentation by the time we got to customer acceptance testing. And we had expected outcomes, which was great. Now what we could really focus in on was the difficult negative testing. The situations where you don't expect to have water thrown on your storage device, or you don't expect to have somebody come through the data center and kick out the cord, and what happens? Those are the real situations that we want to cover, because those situations we really can't account for in our normal positive testing paths. So what we ended up doing was we created common philosophies, right? We didn't force common philosophies. Like, we didn't come in and say, everybody, you will follow the Agile Manifesto. Right? How many people have been part of that conversation? Right? You might like it. It may work for you, right? You may say, oh, that's cool, I get it, right? A lot of people don't like to be told what to do. It's not very enabling. If I said, hey, go get me that drink, go get me a glass of water, you'd say, get out of here, what are you talking about, right? People don't like to be told what to do. They like to be part of a team and empowered to be able to create as part of that team. So as part of this, we created common philosophies. I didn't create those philosophies. The team created those philosophies. We took away methodology. We said, well, forget about methodology, right? What are we trying to accomplish? What are we trying to do? Enable engineering and confidence, build business confidence, work towards reliable, stable baselines of code, continuously improve, create continuous efficiencies, build out loosely coupled, decoupled, highly cohesive tool sets. Right? We're a few. We focused in on delivery of software automation, integration, and testing. So we realized something. Software development is a manufacturing practice. Code goes in, product comes out. A bunch of stuff happens in between, just like an assembly line. The more automation you have in that assembly line, the more widgets you can build. The question is what's the quality of those widgets as they're coming through that assembly line? You want them to be as high as possible. A goal of business is to maximize profitability. Right? So I am in management, so I do have that management lens. Right? Don't get me wrong, everybody wants a quality product. At the end of the day, though, they want to be able to maximize their profitability through that manufacturing process. Keep your costs down, bang out as many widgets as you can, increase that profitability. Right? It's the point of the business at the end of the day. You want to identify your key points of variance. So things like incoming commits, testing, tests that come in to the integration lifecycle, and configurations. So what am I testing against? Everything else should be static. How it goes through that manufacturing line should be totally static. However, what code comes in, commits, what you test and when, and what configurations you test against should be dynamic. Right? I may not want to test against the same quantity of systems that hardware systems that I'm testing further on down the line in my customer acceptance testing. It's a different set of tests against different kinds of configurations. You want to create process based on your philosophies. I'm not a big fan of, well, bring in this methodology and adapt your organization to that methodology. Everybody's different, right? People work different. There's not one, if we ever, bring in scaled Scrum, it's not the magic bullet, right? Understand what your philosophies are, create your process around that. Do what works for your company. Create a quality and integration strategy based on testing types. Things like unit testing, functional feature integration, customer acceptance. Right? Have a strategy around how you're going to ensure levels of quality throughout your entire life cycle. Create a configuration management strategy. So especially in the embedded hardware space, right? So my product is embedded, right? So how are we going to deal with different configurations, and how are we going to test different configurations at different times, right? Like I said earlier, when I'm unit testing, I may not even have a configuration. I might have mocked everything out. So I can run some unit tests, make sure that my basic componentry is working individually, and then promote it to the next level where the tests are much more expansive, and perhaps we begin to throw in some actual hardware to test against. By the time I get to customer acceptance testing, I have large configurations, customer-like configurations, and I'm testing the software in a very, very different way. Identify metrics. So we talked about metrics a little bit earlier. It's not, did my test pass or fail, right? If my tests are continuously failing for whatever reason because they are fragile, rip them out. Don't focus in on those false positives, right? Focus in on and identify the metrics that you need in order to call your software qualified. That might be different for everybody at different stages of your software development life cycle. Code coverage is a great metric. It's not the only metric, though, out there. And it's not just measured at unit testing. Why can't you measure code coverage at system testing? All the way through, you should be measuring that and trying to understand what you're trying to accomplish with that metric. So understand your metrics, code coverage, defect ratios, commits to defect ratios, time to delivery. All of those are metrics that make up a macro view of the quality of your product. And then you need to have tools in place. Tools support your processes, strategies, metrics, and philosophies. And those tools should be consistent to every single component group in your organization. So one component group doesn't use X set of tools, and another component group doesn't use Y set of tools. Everything from their perspective is abstract, right? The only things that matter are the variances that you've outlined. Things like commits, tests, right? What you're testing and when. So changing the integration and testing dynamic. So at the end of the day, everybody's responsible for quality. Everybody. I agree you have specialists that are quality specialists. That's their skill set. That's their craft, right? They need to be evangelists. They need to be able to communicate why that's so important to everybody in the organization. It's not a knowledge that you want to keep to yourself, right? If you are indeed an expert, you want to share that expertise with as many people as you possibly can, because your goal, if you are that skilled, is to build a quality product and everybody around you, and to teach everybody around you how to help build that quality product, right? Quality begins at the requirements collection. If you have really bad requirements, you're going to have a really bad product, right? I mean, how many people have had bad requirements before? All the time. Having bad requirements is not very fun. It actually starts right there, going back and saying, you know what, this requirement is really way too vague. I don't understand what you're asking me to do here. I need more details, because I need not only to understand what I'm going to build, but how I'm going to test this thing. Integration is automated. The majority of testing is automated. And I say the majority because not all testing can be automated. I mean, in some circumstances, perhaps it can be. In many circumstances, it can't be. Certainly with an embedded product, it can't be. We can't automate all of the possible testing scenarios just because we interact with so many other devices in a data center. So here's an example of a promotional model. And it's really unit, functional, feature, integration, customer acceptance, right? But it's much more fun to say, you know, lead, bronze, silver, gold, platinum. It's also a sense of ownership for your organization. Our organization built this. They said, this is how we want to depict code quality across our entire product through our continuous integration pipeline. And we define those terms. Those terms could be whatever you want them to be. But again, it's a sense of ownership. Could we use generic things? Sure. This is much more fun, right? So it starts at the lead level, which is really a bad term for documentation, because lead is heavy and documentation is supposed to be light. So we should change that to like titanium or aluminum or something else, right? Right? But the interesting thing is that we have people in the organization who firmly believe that quality starts when we're writing it down. I mean, how many people have built a house, or have, you know, I should say, have had a contractor to build a house for them? Right? Anybody? Okay, there you go. So if they came to you and said, hey, we're going to build a house, what does it look like? And you're like, yeah, you know, I want it to be big. And they're like, oh, okay, cool, I can build a big house. And they just start working. You're going to say, well, wait, well, what's the blueprint? We don't deal with blueprints. That's, you know, we're all about showing results, right? You probably wouldn't hire that person, right? You want to see what you're going to get. It's the same thing with documentation. Now, it doesn't have to be 75,000 blueprints. It could be a single blueprint. But at least you have an idea of what you're trying to accomplish, right? So things start at the lead level. You have bronze, pre-commit, post-commit, unit testing, functional testing. Silver, automated feature testing, automated integration and interoperability testing. Gold, customer acceptance. Platinum, beta testing, partner testing. And that's a life cycle of promotion, right? Built on top of a DevOps platform that is totally hidden from our engineers, testers, people interacting through this life cycle. They don't have to worry about that. They worry about writing code and then seeing test results. Manual testing in a continuous integration environment. So, you know, of course, automated integration testing, automated integration testing is critical. They can focus in on those core functional feature testing. However, manual testing is really useful when it comes to configuration management in customer acceptance testing. So being able to build out those complex customer-like scenarios that just can't be automated. You need experts to be able to do that, right? And that's the place for manual testing, especially in the embedded product space. Those are product experts, right? They are really, really focused in on that customer acceptance phase. All right, so we put it all together. So this is just an example of how it might look. You have your engineer writing some code. It goes through their unit tests. We have a bunch of triggers in place. It goes to commit, build, and package. We have our automated functional testing. We have our feature testing across product farms, right? If in our case it's farms because we have embedded systems. You know, if it was a software system, it might be, say, Docker deployments, right? That goes through automated integration testing, customer acceptance testing, and then it's releasable, right? And again, our variations are incoming code, automated tests, and then configurations. And I am way out of time.